All right, good morning, everyone. Welcome back.
Good morning.
I guess we all had an adventure last week. I'm sure we all have great stories to tell, but unfortunately we can't, this isn't story time. So we got to get back into this because now we are a week behind. So we've got to somehow find a way to get caught up. And I don't know how we're going to do it yet, but we'll try. Let's see, today we're supposed to be starting 7-7, and we're actually finishing 7-4 and getting through 7-5. So we're, about 2 sections behind. Let's just see how things go. Right now, I do still want to have exam 1 right before spring break, but it probably will not cover all of this material. So let's just see how things go over the next day or so, or over the next week, because we have this week, and then that's next Wednesday is the exam. Is that right? Is it already going to be spring break?
Yes, sir.
Wow, that's crazy. Okay, well, it's the way it is. So we'll just see. I mean, we'll know it. We'll know at the end of this week, end of Wednesday, how many sections will be on the test. But let's cross that bridge when we get to it. Okay. Anything anyone needs to ask, or any questions before we begin?
Oh, go ahead, man.
Yeah, so for the 7-4 homework, after we finish today, we'll finish that part of the homework. Okay.
Yeah, I extended the deadlines on the homeworks, and I pushed those out pretty far, and I'm going to have to go through the schedule and just redo everything. Again, just give me some time to do that. So I think today's the first day, like I've actually sat down at the computer. So I've had a lot of other things going on in the house. So anyways, I'll get everything sorted out. Just give me a couple of days. But you should be able, go ahead, Joshua.
Sir, we're supposed to be up to, we stopped halfway at 7-4, correct?
Yeah. So after today's class, you'll be able to finish 7-4 and 7-5.
Okay. Okay, I did 7-5. We stopped at 17 of 7-4. Okay, got it.
Okay. All right, so let's get into this. So last class, we were talking at the end about this idea of a reference angle. And the idea was that if you're given an angle, doesn't matter what it is, theta, that the reference angle for theta is another angle called beta, which is just the angle between the x-axis and that angle theta. So this right here would be beta. And it's not the same angle as theta. Okay, it's not the same angle, but we can use it to figure out the values of the trig functions. Okay, and I'm about to go through a couple of examples of that. So that's what we were doing at the end of class last time. Here were some examples. If you were given 165 degrees, then the reference angle would be 15 degrees. That's the angle that would get you from the x-axis up here to this angle. And we did a couple of these. So let's see how we can use that to find the exact value of each of the following trig functions. So the first one, sine of 135 degrees. First thing you want to do is part A. So you want to go to 135 degrees, which would put us in the second quadrant, somewhere in the second quadrant. And that is because I know that this is 90 degrees and this is 180. So I know 135 is somewhere between there. And then what I need to do is figure out the reference angle, which would be this one. Okay, and that, the way I can find that is just by simply doing 180 and subtracting 135. And that would be 45 degrees. So this reference angle is 45 degrees. Now here's the way things are going to work. What you're going to do is you're going to, since we're looking for sine of 135, okay, remember that when we were talking about the circle, the unit circle and those common angles that you should know, let me get back to that. It's actually from a couple of classes ago. Here we go. Remember this thing? Where we were like, okay, you need to know 30, 45, 60, you need to know these values. And then sine is just the y coordinate, cosine is just the x coordinate, right? And I said, the sooner you memorize that, the better off you're going to be. Well, here's how we're going to use it. And I should also reference last class. We talked about this all students take calculus. Remember this? All students take calculus. And this was a thing that you could use to remember in each quadrant which trig functions are positive. So all of them are positive here, just sine is positive here, just tangent, and just cosine. So we're going to use that along with those common angles to answer this question. So what we do here is we will look at 45 degrees and we will take sine of that instead. So we're going to do sine of 45 degrees. And that, going off of that, those common angles, right, going off of this thing, at 45 degrees, sine is the y coordinate is √2/2. Okay, so that's not our answer. Okay, we just know that this is √2/2. Now, because we are in the second quadrant, right? Since we are in the second quadrant, we know, again, all students take calculus. We know here in this quadrant, the sine function should be positive. So the reference angle is going to give us the correct value of the trig function, but we just have to determine whether or not it's positive or negative. And that's where we use the all students take calculus. So since sine is positive here, then the answer here is in fact the same answer, √2/2. And it's positive. I don't need to put that. Does that make sense?
Yes,
Okay, good. All right, let's do the next one, cosine of 600 degrees. So I'm going to do cosine 600. So I need to figure out where 600 degrees is. So what I would do is I would get my calculator and I would just do like, oh, turn it on. I would do 600, I would take away 360, and that would give me 240 degrees. So 600 degrees is like going all the way around and then going another 240 degrees. So where's 240? This is 90, this is 180. You need to know these, 270. I know 240 is going to be somewhere in that third quadrant. So somewhere over here, that angle, that's my 240. I'm going to put 240 here just so I can remember. It was 240, right? When I got on my calculator and I subtracted 360 from 600, I got 240. So that's 600 degrees, right? Now the reference angle is going to be the angle from here to here, all right? From the x-axis to that angle. And so I need to know the difference between these two. So I'm just take 240 and subtract 180. And what does that give me?
60.
Right, so 60 degrees. So what I do now is I say, okay, really, I'm just going to look at cosine of 60. So that's where I go back to the common angles. Cosine will be the x coordinate at 60 degrees. So I go back over here, here's 60 degrees. The x coordinate is 1/2. With me?
yes.
I'm going to write that down. It's 1/2. Now, that's not necessarily my answer yet. I still need to figure out whether or not I'm positive or negative. So this again, all students take calculus. Well, this is saying that tangent is the only trig function that is positive in this quadrant. And we want cosine, right? So my answer can't be a positive number. So cosine of 600 degrees must be equal to that same number, 1/2, but it's got to be negative because I am in this quadrant, in the third quadrant. Questions?
So we use so it's going to be negative since it's in that third quadrant.
Yes. The all students take calculus is telling you where what trig functions are positive. And remember, if you go back and when we were talking about, when I say all trig functions, I'm talking about these three. Okay. I'm only talking about sine, cosine, and tangent, because remember the reciprocals are the same, right? The reciprocal of sine cosecant would be the same as sine, and the reciprocal of cosine would have the same sign as cosine, right? Secant would have the same sign as cosine, and cotangent would have the same sign as tangent. So this is telling me, let's just say in this third quadrant, T here means tangent and cotangent are positive. Sine and cosecant are negative. Cosine and cosecant, sorry, sine and cosecant are negative. Cosine and secant are also negative. All right, let's do another one here.
I have
This
a question.
one, yeah, go ahead.
Would we write the solution as cosine of 600 equals -1/2?
Yes.
Okay.
Yes, because we're not saying cosine of 60 is -1/2. We are saying cosine of 600 is. So all this part is to help us get the answer off of those common angles, right? If they would have given us like cosine of 600 2 degrees, we couldn't do this, because then this would be cosine of 62, and that's not a common angle.
Is there a way to solve cosine of 602 degrees when we
Not
get
by,
to a higher
not
level?
by hand. Not by hand. We would just use our calculators for that. Well, I take it back. In Cal 2, there's a way, but not here. Yeah. Okay, so let's look at the next one. Cosine of 17 pi over 6. All right, so cosine of 17 pi over 6. All right, so I know that we've talked about how you can count your way around the circle. And in this case, I'm doing 17 of these pi over 6s. Pi over 6 is something you should just be like, oh yeah, that's one of my common angles, pi over 6. And you could count your way around. I'm going to do something a little different this time though. All right. Just like I did with 600, you know how I got on my calculator and I did, it doesn't even remember. Okay, yeah, there we go. I did 600 and I took away one full revolution, which was 360 to get me to the 240. I want to do something similar to that here. What I'd like to do is I'd like to take 17 pi over 6, and I'd like to subtract a full revolution. Now, a full revolution would be 2 pi, right? Now, in order to subtract these two, I have to have a common denominator. So I want to look at 2 pi as being 2 pi over 1 and multiply the top and bottom by 6. So I get 12 pi over 6. So all I'm saying is that 2 pi is the same as 12 pi over 6. And now I can put these together. And if I put those together, 17 pi's take away 12 pi's, I get 5 pi over 6. Now, you didn't actually need to do this. You could have just counted your way around like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could have done that. But by subtracting 2 pi, what I'm allowing myself to do is not count as far. And this is going to be useful in a little while in the next section. So I'm just going to count 5 pi over 6s. So this is one of them, 2, 3, 4, 5. So I'm counting by 30 degrees, basically. This is right there. That right there is 5 pi over 6. Now, the big question is, what is the reference angle then? So who can give me the reference angle? What's
It's gonna
that?
be 30 degrees.
30 degrees, or in radians,
Pi over 6.
pi over 6. Are there any questions on where that's coming from, the reference angle? All right, so we want to know what is cosine of pi over 6. So when we look at that means we go back to that common angle. Pi over 6 is 30 degrees, and cosine is the x coordinate, so it should be √3 over 2. square root of 3 over 2. Now all we have to do is determine whether or not it's positive or negative. So I just go back again to the all students take calculus. And I'm looking at where this 17 pi over 6 lands. And it lands in the second quadrant. And in the second quadrant, the only trig function that's positive is sine, which means cosine should be negative. And that means my final answer here is negative root 3 over 2.
Just for confirmation, I was working on some problems earlier and I came across tangent of 30 degrees. Is it root 3 over 3?
Tangent of 30 degrees?
That
Yes,
would
sir.
be sine over cosine, right?
Yeah, so you can look at tangent in two ways. You can look at it as being the sine over cosine, or you can look at it as just being the y coordinate over the x coordinate. So if you go back over here, here's 30 degrees. Tangent of 30 would be the y coordinate, which is 1/2, divided by the x coordinate, which is root 3 over 2. And then when you're doing a fraction divided by a fraction, that can turn into the fraction on top times the reciprocal of the bottom. And then your 2's will go away and you get 1 over root 3. And that would be correct as an answer, but you could also rationalize a denominator. So you go root 3 on top, root 3 on the bottom, and that'll give you root 3 over 3. So yes, I think that's what you asked. Is it root 3 over 3?
Yes, sir.
Uh-huh,
Thank you.
that would be correct. Okay, well, the next one is actually pretty similar to that. It's tangent of negative pi over 3. It's not the same problem, but it's similar. So tangent of negative pi over 3. Let me do that. So tangent of negative pi over 3. All right, so I need to figure out where negative pi over 3 is. It's a negative angle, which
That would
means
be
that
30 degrees in the fourth quadrant, right?
60.
Oh,
I
yeah.
think,
sorry.
yeah, 60. So we're going to be going clockwise, right? Because it's a negative angle, and we want to rotate by pi over 3, which would be somewhere around here. Okay, so just remember, this is negative pi over 3, right? That like that, and then this up here would be positive pi over 3. Just so it's just the angle, but rotated the other way. Now, this is kind of weird, but we want to know what the reference angle is. The reference angle is this angle, but always measured as a positive angle. So our reference angle should be positive pi over 3. So what we want to know is what's tangent of pi over 3. And then we go to, again, that very important picture from a couple of classes ago. And we go to pi over 3, which is 60 degrees. And we go, and let's just do it what we did with Joshua there a second ago. We're going to take the y coordinate and divide it by the x. So we're going to take this and divide it by this. So this is going to be root 3 over 2 over 1/2, which is the same as root 3 over 2 times 2 over 1, right? Division is the same as multiplication of the reciprocal. The 2's go away and we just get root 3. Now, this is not our answer, all right? This is not our answer. This is just this is the numeric value of our answer. We need to determine if it's positive or negative. So all students take calculus. In the fourth quadrant, which is where this negative pi over 3 is, only cosine is positive, right? And we want to know what tangent is. So that means it's got to be negative. So negative root 3. Any questions? All right, that's how we can use reference angles. All right, that's the use, that's why they're useful. All right, next thing we're going to do, make sure I got that, okay. Next thing we're going to talk about is, hold on, this seems out of place, but I think it's right. Yeah, okay, so this is a different problem, all right? But this is going to be using that whole, what do you call it? It's not the reference angle, but it's all students take calculus, okay? It's going to be using that to help us try and figure out. So we're given cosine of theta is -2/3, right? We're given that. And we're told, this is very important, we're told that the angle is between pi/2 and pi. And then we're asked to find the exact value of all the other 5 trig function values for that angle. All right. Now, cosine of theta being -2/3, when you look at this, this is not one of our common values, right? Remember, cosine is the x-coordinate on the unit circle, and -2/3 never appears here. So this is not a common angle. Do y'all see that? We can already say it's not a common angle. All right, so here's what we're going to do. This is going to be tricky, okay? It's the first time we've done a problem like this, so please ask questions if you have them. Here's what I'm going to do. I'm going to draw my XY axes, and I'm going to tell myself, okay, I'm between pi/2 and pi, all right? That's where I am. So that eliminates this quadrant, this quadrant, and this quadrant, right? I'm somewhere in here. That's where my angle is. Now, remember that cosine of theta, by definition, when we were talking about right triangles, cosine was the adjacent side of the right triangle over the hypotenuse. That came from the idea of, or from the Sohcahtoa, right? And I should mention this to you. The way that I'm showing you this is not necessarily the way the book shows this, all right? I always teach it the way it makes sense to me. And so if you go and try and read the book, it may not match up. We'll get the right answer, okay? But this is what makes the most sense to me. So that's the way I always present it to my students. All right, so what we're gonna do is we're going to draw a right triangle, but we're gonna be doing it in the second quadrant. So I'm gonna draw a triangle that goes out like this and down and over like this, all right? And the fact that I have cosine of theta equals -2/3, that's what was given to us, right? We were given that. I am going to decide where I'm going to put this negative, because remember, a negative in front of a fraction can be either on the top or on the bottom. I'm going to put the negative on top, and I'm always going to put the negative on top. If there's a negative, I'm always going to put it on top, because that is going to represent my adjacent side. So on this triangle, do you all see that the adjacent side is right here? -2, it would be like from here to here. Think of it as an x coordinate. If you want to move from here over to here, well, we're trying to get up to this point right here. You would have to move to the left too. Now, I know that already should bother you, because we're saying that the length of a side of a triangle is negative, right? And we've never really ever said that before. But I want you to look at more of like, it's a position. It's how far we move. So we move to the left too, right? Now, any questions on that? If this is -2, what's the 3? Which part of my triangle?
The hypotenuse.
The hypotenuse. Now, we will always make the hypotenuse the positive number, okay? The hypotenuse will always be the positive. Now, if that's the case, right? If this is our triangle, we know how to get this side, don't we? I'm going to call it y, because it is the y coordinate, isn't it? Shouldn't we be able to find that? We could use a Pythagorean theorem that says -2 squared plus y squared must equal 3 squared, right? That's just a squared plus b squared is c squared. I didn't need the parentheses around the y. I do need the parentheses around the -2 though, because what's -2 squared? 4, right? And just a little side note, these two do not give you the same value. -2 squared, that's -4. -2 in parentheses squared is +4, right? Because order of operations says you have to do this first, which is 4, and then make it negative. Here, this is saying -2 times -2, which is +4. So there's a big difference between those two. So for us, this is 4 plus y squared must equal 9. Now you subtract 4 on both sides, so you get y squared must equal 5. And then you take the square root. Very important step now. When you take the square root of this, you get plus or minus, don't you? Plus or minus. Whenever you take the square root of something, you should always get plus or minus the square root of 5. Now, which one is it going to be? The plus or the minus and why?
The positive.
Positive y.
I have a question.
Yes,
If it were in the third quadrant, would it be negative square root of 5?
exactly. That's the point. Very good. So right now we are going to take the positive root 5, not because we want to just always pick the positive. It's because of the quadrant we're in. See, we're in the second quadrant. So think about your y coordinate. Where's your y coordinate in the second quadrant must be up, right? You have your y value has to be above the x-axis. So it has to be a positive number. So that means that this must be the positive, not the negative. Okay. Now, Maddie was asking, what if our triangle was down here in this quadrant? Well, then we would take the negative square root of 5, all right, instead. So this is going to be positive root 5. Okay, now at this point, we have the adjacent, the opposite, and the hypotenuse. We have all of them, don't we? So we should be able to put all the trig functions together. So let me write them all out. We have sine theta, cosine theta, tangent theta. The reciprocals are cosecant theta, secant theta, and cotangent theta. All right, so we were given what cosine was, right? Cosine was the negative 2/3. All right, let's get sine. Working off this triangle, sine would be the Sohcahtoa, it would be opposite, right?
Square root of 5/3.
Root 5/3, good. Okay, what about tangent? Who wants to give me tangent? Should I call on people? Are you all ready?
Square root of 5 over negative 2.
Square root of 5 over negative 2. So that's coming from Sohcahtoa. Tangent is opposite, which is root 5 over adjacent, root negative 2. Good. And then all the others are just flip those over, right? I don't need to go through that. Flip them. Flip it. And flip it. And from my experience on the computer, when you're doing your homework, it is taking these answers. You're not having to rationalize them. What you do have to do is if you have square root of 20, the computer does want you to simplify the radical, but they let you leave radicals in the denominator, which is good. I'm happy that they do that. Okay, are there any questions on this? This is a really good, important problem. So Maddie had asked the question, what if it was in the third quadrant, right? What if it was in the third quadrant? So here's how the problem would have been in the third quadrant. They would have done this. Instead of that, they would have said pi less than theta less than 3 pi over 2. If we had the exact same problem, right? Except they gave us this instead of this, then what we would have had was we would know that we have to be between pi and 3 pi over 2. So we couldn't be here, couldn't be here, couldn't be here. And then when we draw our triangle, watch the way it would look. It would go like this, this, and this. Then we would have negative 2 here and 3 here, because it would still be adjacent over hypotenuse. But now when we solve for this side, we would take the negative root 5, because to get to that point, you have to move down. And then you just do all the same things. It's just going to change some of the signs of things, right? Like sine theta would be your opposite, which would be negative root 5 over hypotenuse, so over positive 3. So that would have been negative, and then cosine would have been the same. Tangent would have been positive, wouldn't it? Because it would have been negative root 5 over negative 2. So you would have had a positive here. Okay, any questions? I like those problems. I mean, I can guarantee you'll see one of those on a test. All right, here's another one. I like this problem too. tangent of theta equals -4. And sine of theta is less than 0. So in the previous problem, they gave us a trig function, cosine of theta, and they gave us the value, and it wasn't one of the values that we recognize from this circle, right? Like, we don't recognize this as a common angle, right? And then they gave us a restriction on theta, which forced us into a quadrant, right? That forced us into one of these quadrants. Here, this next problem, they're giving us tangent theta as -4. That again is not a common value that we recognize. Do y'all agree? That's not one of the common values. But they're not giving us a restriction on theta. So we need to somehow nail down where we are. Like what quadrant is this angle in? Can somebody tell me what quadrant we have to be in?
It's either gonna be, well,
The
shoot,
third quadrant?
I think I heard third. Is that what I heard?
Either the third or the fourth,
Third or the fourth. So why third or fourth?
because it says that sine is negative.
Okay, so
And-
let's start with that. Sine is negative, right? So let me write over here, all students take calculus. Okay, so
It would have
if
to be in the
sine is
fourth
negative,
quadrant.
if sine is negative, then it can't be in the first quadrant, right? Because all of them are positive there. It can't be in the second quadrant because sine is positive there, right? It could be the third because only tangent's positive, and it could be the fourth because only cosine's positive. So do y'all agree from what's in yellow, I know that I must be in one of those two from the yellow part, right? So I can eliminate these. All right, but they also tell us that tangent of theta is -4, right? So they're telling us that tangent is negative. Well, we can't be in the third quadrant then, right? We can't be in the third. For tangent to be negative, we'd have to be either where? Where would we have to be for tangent to be negative?
The fourth quadrant.
Fourth or the second, right? In the second, tangent is negative. But we already know we can't be in the second because of the sine part. So that means that we have to be, we can throw this out, we have to be in the fourth quadrant. So the sine being negative is not enough. You also need the fact that tangent is negative. Tangent being negative wouldn't have been enough either, right? If they wouldn't have given us the sine, they just told us tangent is negative, then we would have two different quadrants it could have been in. So it's the combination of both of those pieces of information together that makes you, forces you into the fourth quadrant. Is that clear to everyone? Any
Yes.
questions? All right, so I'm just gonna, that was just for me to figure out what quadrant I'm in. I'm in the fourth quadrant. So I'm gonna draw my little reference triangle over here like this. Notice that the reference triangles that we draw are always going to start at the origin. That's going to be your hypotenuse out to some point, and then it drops back down to the x-axis. So just as a real quick reference, these are all the possibilities of the triangles you could have. You could have a triangle that went that way, like that, or like that. Those are the different shapes of the triangles you could have depending on which quadrant you're in. All right, so tangent, I'm given that tangent of the angle theta is -4. I'm going to write -4 as a fraction, -4/1. Now, tangent using Sohcahtoa, right? Tangent is opposite over adjacent. So this is the opposite side, and this is the adjacent. Because we're treating this angle like right in here. I'm going to put a little dash. We're treating that as our angle right there. So it's almost like this is our theta, kind of. Theta actually theta is this, but it's almost like a reference angle we're using here. That's the opposite side of the triangle. So my question now, and let me call on someone. How about, let's see. Is Michael here? No, okay, how about Lauren? Lauren, you here? How about Sierra?
Hello, I'm here.
Hi, Sierra. All right, so Sierra, I want to help. I want some help labeling this triangle. So the tangent is opposite over adjacent, right? So what am I going to label my opposite and adjacent? You tell me.
Opposite would be -4,
Mm-hmm.
and then adjacent would be 1.
Okay, yes. Now, could I change it? Because remember, I've said that negatives can slide top and bottom. It really doesn't matter where the negative sign is. Like in general, if you're looking at a fraction. So could I have, you want me to make the opposite -4 and you want me to make the adjacent 1, right?
Yeah.
Okay, do I have the freedom to switch those?
I personally wouldn't, just because the opposite is going down into the negative.
That's right. So you do not have the freedom to switch them. All right. You have to think about what the 1 represents and what the -4 represents. -4 is the y coordinate, right? Think about this as a point. To get here, you got to go down, right? You got to go down. So that's got to be the negative number. And then to get to that point, you have to go to the right, which is a positive number. All right. So we have to be real careful with that, because you don't get the flexibility of just assigning the negative wherever you want here. You have to pay attention to which quadrant you're in. All right. Okay, so once that's labeled, now we can find the hypotenuse, right? Because that's the one thing we're missing here. Right, this is the hypotenuse. That's one thing we're missing. Sierra, you're good. Okay. So for the hypotenuse, we're just going to do adjacent squared plus opposite squared. So a squared plus b squared equals the c squared. I'll just call it c. And then that's going to be 1 plus 16 equals c squared. So we get 17. And take the square root, we get plus or minus root 17 is c. And let's see here. Is Brianna here?
I'm here.
Hi, Brianna.
Hello.
Okay, so what do you think? Is c positive or negative root 17, and why?
I almost want to say it's negative
Because of where, because it's down?
because it's going down. Yeah.
Okay, so the rule of thumb that we'll use is the hypotenuse is always going to be positive.
Okay.
Okay, always. The only thing that you have to worry about the signs on are the adjacent and opposite. Those are like your x and y coordinates. Think of the hypotenuse as almost like a radius of a circle. And so it's always going to be positive. So we'll just make it root 17.
Awesome.
Okay. All right. Now, once we have all 3 sides, it's just plug in, chug, right? Just plug in and figure out. So sine theta, cosine theta. I'm going to do this a little faster. I'm just going to do the first 3, and then I know y'all can just flip these over, right? So we know tangent theta was -4. Let's see. Karen, is Karen here?
Yes, I'm here.
Karen, okay, give me sine theta. If you're not sure, just say you're not sure. It's okay.
I'm not. Sorry.
Okay. Oh, sorry. All right. So sine theta, Karen, by definition, sine using Sohcahtoa. What does this mean? Karen, sine is what?
Opposite over hypotenuse.
Okay. So what's our opposite?
So it's -4 over root 17.
Yes. Okay. Good. There you go. See, wasn't that bad, was it?
Sorry.
All right. All right. Okay. Let's see. And then the cosine would just be adjacent, right? So that would be 1 over root 17. And that's it. And then the reciprocal functions, just flip those over. I won't do those. All right. Does that make sense, everyone? You use the given information to nail down what quadrant you're in. You draw a triangle. You label the sides that you're given. from that, you make sure you get your signs right, use a Pythagorean to get all the sides, and then just Sohcahtoa.
Would there ever be a problem where they don't give you both of the functions? Like,
They
is
would
it even
never-
possible?
They would not ever give you not enough information. Like you would always have enough information to nail down the quadrant. It depends on how they would do it. Like in this problem, they give you tangent and sine. So that was it. You're able to figure out what it is. In the previous problem, they gave you cosine, and then they told you that the angle had to be between here and here, right?
Okay.
Now, let me show you another example. I'm not going to work through this whole example, but what if I told you that cotangent of theta was -3? Now, let me think for a second. And I told you that theta was between pi over 2 and 3 pi over 2. So the question is here, what quadrant are we in? So you start off, let's start off with this part. Right, we have to be between pi over 2 and 3 pi over 2. So here's pi over 2, this is 3 pi over 2. So it can't be here and can't be here. Agreed?
Agree.
Okay, now cotangent is negative. So think about all students take calculus. So, what do you think?
Well, hold on. How do we our parameters for where this line is like a straight line? So wouldn't we have to know if the angle is positive or negative? Because it could be in either side then, correct?
It could be on either side. I'm not
It
sure.
could be either side on the x-axis. It could be on the left side of the x-axis or the right side, depending on how do we know we're are we always measuring a positive angle?
Well, in this particular problem, they're telling us that theta has to be positive.
Okay.
Right? They're saying theta has to be between pi over 2 and 3 pi over 2. So the angle has to be between here, or it could go all the way to here. So they're telling us it's somewhere in that range.
Okay.
Our angle's got to be somewhere in this range right here. In this particular problem, they're telling us that. I think what you're asking is, could we have a negative angle? Like come the other way, is that what you're saying?
Yeah, because we would just swap quadrants, right? We would just mirror.
Yeah, I see what you're saying.
that.
Yeah. Yeah, but it's positive, so we have to assume it's the second and third quadrants.
Okay, thanks.
Will the angle always be positive? Can we just assume that?
Well, I think most of the problems I've ever seen in textbooks at a pre-cal level have always been positive angles. Yeah. I'd be surprised if there was an example that had negative, but I wouldn't do that. I don't think on a test, but in general, later on in math, like that, it may not be positive. It could be negative. It's the same principle. You're just trying to figure out what quadrant you're in. Okay, so we still don't know where we are. We're either in 2 or 3, right?
It would have to be
So-
the second quadrant, right?
Okay, so why would it have to be the second?
Cotangent is negative, so and it's -3, so the reciprocal would be -1 over 3, or 1 over -3, depending on how you look at it.
Yeah, the fact that cotangent is negative means that tangent is negative, right? Because they're just reciprocals, right? So if you take -3 and flip it over, it'd become -1/3. So this tells you that tangent has to be negative. But all students take calculus tells you that in the third quadrant, tangent is positive, right? And so we can't be here. And the second quadrant, only sine is positive, which means tangent is negative in the second quadrant, which means that cotangent is negative in the second quadrant. So we have to be here. So again, it's a matter of using this information to try and nail down what quadrant you're in, but you'll always be given enough to get the quadrant. They'll never give you information and make it where you could be in 2 different quadrants, because then you can't give them an answer, right? You can't actually figure it out. You could figure out 2 different scenarios, but you couldn't figure it out for sure. Okay, we good? All right, so this is a problem that shows up on the homework for 7-4, and I thought I'd go through it because it is a little bit confusing. Sine of 10 degrees. Now, you may get a different version of this, but the method of doing this is the same. So what's tricky about this problem is that these are not common angles. 10 degrees, 145, 190, 325. None of these are common. And also, they are not, do you remember what we called two angles that would add up to be certain?
Complementary.
Yeah, do you remember that? And there was a property that if the two angles added up to be something, then they would cancel each other out, like they would be opposite or something like that. Do you remember that? It's been a while. Let me bring it up here. I know it's, where is it? There it was. No. No. Coterminal. No, I'm not gonna be able to find it. It might have been the day before. No, okay. Anyway, it's not that, okay? It's not that case either. So here's the way I think we should look at this. All right, where's 10 degrees? All right, so let's just figure out where 10 degrees is. Let me do that different color. Okay, 10 degrees, I hope we would all agree is like somewhere in here. All right, that's 10 degrees, somewhere around there. Now 145 degrees, let's see where that is. 145 would be not quite 180, so I don't know, somewhere over here. That'd be 145. Yeah. All right, now let's look at 190. Where's 190? Well, wait a minute. 180 is all the way across, right? And so if we do 190, it would be 180 plus how much?
10.
Plus
10 degrees, right? So like this is 10 degrees right here. The whole thing is 190, but that's 10 degrees there, right? All right. Let's keep going. Let's see, 325. Where's 325? So that would be almost 360. It'd be somewhere around here, right? That would be 325. Okay, just curious though, what would that little reference angle be? What would that be?
35.
35? Hey, wait a minute. Isn't this reference angle right here also 35? Isn't it? Like to the red one, right? This little reference angle right there.
Oh,
Because that's the red one is 145. So add another 35, you'll be at 180. Yes?
Yes.
Okay, now this is like the big kind of eureka moment for this one. These are all sines, aren't they? And that means they're all the y coordinates, aren't they? So let's start with that 10 degrees. If we go to that 10 degrees, right there, that has a certain y value, doesn't it? We don't know what it is, but that y value would be sine of 10 degrees. Agree? What can you tell me about the 190, that this y coordinate? You don't know what it is, do you?
But it would have the 10 degrees still, correct?
It would be, but would it be
Negative?
positive or negative?
It'd be negative.
Negative, yeah.
It'd be negative, right? So what I'm trying to get you to see is that whatever this y value is the same as this y value, except one of them is positive and the other one's negative. So what would happen if I add those two together? So
They
this
would
is,
cancel out.
yeah, they cancel. The y coordinate at 10 degrees plus the y coordinate at 190 degrees. If I add the two, then they should cancel each other out, right? They should just go away. I don't know what the values are, but I just know that they're the same, just opposite in sign. Can you say the same thing about these two? Think about the y value from here to here, whatever that y value is. Wouldn't that be the same as this y value from here to here? Because they have the same reference angle, right? They have the same reference angle. They would just be, one of them would be positive, the other one would be negative. So those two right there should cancel each other out. Which means our answer should be what?
0.
0. Now, if you wanted to do this more mechanically, what you could do, you would still have to recognize that what's going on here, but you could do this. You could draw a triangle for the 10 degrees. Okay, that's your 10 degrees here, right? And then you could do the reference triangle for the 190. And then if you look at it that way, then you can see that sine of 10 degrees should be equal to the negative of sine of 190. That's basically what I'm saying here, is that the y coordinate off of this one is equal to the opposite of the y coordinate off of this one. That would be your 190. I hope that makes sense. All right, we need to move on. Y'all ready? All right, we are moving into 7.5. So 7.5 is called the unit circle. And we've already talked about this, which is, I mean, that's the good news, is that I've already introduced you to this idea. All right. I told everyone, hey, you need to learn the first quadrant. Here are the angles, 30, 45, 60, or you could look at pi over 6, pi over 4, pi over 3. And then here are the values off of that. And the important thing is that when we talk about the unit circle, we are talking about a circle of radius 1. That's what unit, that's where the word unit comes from, 1 unit. So that's what we've been using, right? It's been very helpful, right? And we defined what all the trig functions were here, right? We said, okay, sine is just the y coordinate, cosine is just the x coordinate, tangent is the y divided by the x, and then we said that these are just the reciprocals, just all those flipped over. So if this is y, cosecant would be 1 over y. If cosine is x, then secant is 1 over x, and so on and so forth. Okay? So we know how to do this, all right? That's the good thing, because when I showed you this unit circle thing earlier, I told you this is going to come later. Let's just look at it now. And it's been very useful for us. So here it says find the values of sine, cosine, tangent, cosecant, secant, cotangent. If there's a point that lies on the unit circle that has the coordinates, now pay attention to this, it's -1/2 √3 over 2. So that would be this point up here. So it's that one right there. Oy, oy, oy. So all you need to know is that this is one of our common values. So this is our x and this is our y, right? And this is on the unit circle. So to find out what, sine of the angle, they're using t here, not theta. Sine of t, I just write the y coordinate. Cosine of t, I just write the x coordinate. Tangent t, I just take the y divided by the x, which is the same as taking the y multiplying by the reciprocal. I'll still have a negative on the bottom, so I'm just gonna make this -√3. And then the other 3 are just all of those flipped over, which I'm not going to write down. There's nothing new here, right? Nothing new? Is everyone comfortable with that? No questions? All right, because as soon as we get that, we're going to move on to something new. All right. So now what we're doing is we're generalizing. What I'm showing you right now, let's put a little asterisk next to this. This is the most general form of the 6 trig functions that we're going to see. So there's really like 2 ways to define the 6 trig functions. You can use right triangles and use Sohcahtoa. Okay, that's one way. The second way is to use a circle of radius r. Notice that that radius is not 1. The radius is r, all right? If we have a circle of radius r and we have a point on that circle, x, y, then we define the trig functions as follows. You know what? I need to get rid of this. I'm not going to use that. It's not consistent with mine, but that's okay because I can write them down. This will work. Okay. Okay, here we go. So sine of theta will be equal to, remember how on the unit circle was just the y coordinate? That's all it was just the y coordinate? Well, if it's not the unit circle and the circle has a radius of r, then it's always going to be the y coordinate divided by the radius. That didn't come out good. It's y over r. Cosine of the angle will be not just the x coordinate, but the x coordinate divided by the radius. Tangent of theta will be, well, that doesn't change. It's still the y divided by the x. Now the reciprocals are just, just flip those over. Okay, so we're going to flip them. R over y, secant theta equals x, r over x, and cotangent of theta equals x over y. So the way I want you to kind of see this right now is that when we were doing the unit circle, right, what was the radius on the unit circle?
1.
1. Okay, so if I replace all these r's with 1s, do you see that it's the same formulas that you already had? Like replace that r with 1, you just have y. Replace this r with 1, you just have x. Replace that with 1, you have 1 over y, which is the reciprocal of y. So this is a more general form. It applies to any circle. All right. So that's good news, and you're about to see why. Okay. So it says here, find the exact values of each of the 6 trig functions of an angle theta if 4, -3 is a point on its terminal side. All right, so here we go. I'm going to draw XY plane. I'm going to plot the point 4, -3. And everyone in this class should be able to plot the point 4, -3, right? So go 4 and then come down 1, 2, 3, -3. And I'm going to plot a point here. And what they're telling us is that this point lies on the terminal side of an angle. So we have an angle that maybe does this. And so that's our angle theta. And they would like for us to figure out what all the 6 trig function values are for that angle. So what I'm going to do here is I'm going to label this point. I'm going to label it as 4, -3. And do y'all kind of see that this creates a right triangle? Do y'all see that? What I'd like to know right now is what's this? Because that's the radius, isn't it? The distance from there to there. How could we get that?
Pythagorean theorem.
Yeah, Pythagorean. We've been doing it. And we know the sides. We know the 4 and the -3 make up the sides of the triangle, right? But I'm not going to draw a triangle. I'm just going to use that to write down 4 squared plus -3 squared equals r squared. See, I'm using a new definition. I'm not drawing triangles anymore. I'm just using the definition that we just got, this right here. Okay. 16 plus 9 equals r squared. And that's 25 equals r squared. And that means that r is 5. The radius will always be positive. Okay, radius will always be positive, just like the hypotenuse of the triangle is always positive. So now I have everything. I know x is 4. I know y is -3. And I know that the r is 5. And once I know what all of them are, go ahead.
So if this was in a different quadrant, r would always be positive.
Always. Yep.
Okay.
Yep. Always positive.
So once we find everything, we just plug in now and then that's it.
That's it. So sine is y over r. So let's see. Anna Marie,
Yes.
go ahead. What's sine then?
-3/5.
-3/5. So we're doing y over r. So it's -3/5. And then cosine would be, you want to keep going?
Sure. It'd be 4/5.
4/5. And finally, tangent,
-3/4.
-3/4. So I think it would be useful to you to try and memorize these as soon as possible. And I don't think it's a lot more to memorize than you already had memorized. Hopefully everyone understood that off the unit circle that cosine of the angle was the y, I'm sorry, cosine was the x coordinate, sine was the y coordinate, tangent was the y over the x. Now all you're doing is adding the r in there. You're doing cosine is x over r, sine is y over r, and then the tangent stays the same. Now the other reciprocal ones we could get, right? I'm not going to do these. Cosecant, theta, I'll just do the first one, would be 5/-3, and then so on and so forth. All right, is that good? All right, so now we're going to start talking about some things that are going to seem weird at first, but we're leading ourselves up into the next sections. We need to start talking about the domains and ranges of the 6 trig functions. And this can get kind of complicated. So let's start with the sine function. All right, this is a table that summarizes everything I'm about to do. All right, this is a summary, but I need to explain why it's this. Okay, so let's start with the sine function. So when we talk about the sine function, let's go to the definition we just gave the sine one. This is y over r, right? Y over r. So if I draw an angle, okay, if I have some point somewhere, right? Some angle going through it, right? This is x, y, that's that point, and distance from here to here is r. Then sine is just the y coordinate divided by r. Now we're trying to look at the sine function as a function. So think about it this way, just to get your mind working correctly here. Back in college algebra, if I gave you this function, f of x equals square root of x, this had a domain. There were certain things you could not plug into this, right? So the domain of this are all the things that you can plug in, right? All the things you can plug in. So there's a couple of ways to write this, but a lot of time, what we like to use is set builder notation. Have y'all seen this? I'm going to write it down. Let's see if you've seen this. You do the set, so you use a brace, the set of x's, then you use a bar. That bar stands for the word such that x is greater than or equal to 0. Close. Have y'all seen that before? It's
Yes.
the set of
Yes.
values x such that the x's are bigger than or equal to 0. That would be the domain of this. Another way you could write that's called set builder notation. You could also use interval notation, which is something like this, like x must be greater than or equal to 0. That's this written down, but as an interval, that's the interval 0 to infinity. So this is called interval notation. So there's basically 2 ways we like to write sets in math, either set builder or interval notation. They both have pros and cons. Set builder, you can design some pretty crazy sets using set builder. Interval notation is really just for numbers on a number line. There's one thing missing from this that a lot of times we don't write, but I want you to start to write, and that's put x, and this is like a little e, a backwards e. And that stands for x is an element of this set. And if you write it this way, then you don't ever confuse this with a point. Like if I write If I write 3, 4, is that the 0.34? Or is that all the numbers between 3 and 4? It's confusing if I write it that way. So if I put x as an element, then that means I'm talking about an interval. Okay, that was just to get you to think about domain. There are certain things you can and cannot plug in. So coming back up to this, if we look at this as a function of theta, that means you're going to plug in an angle. The question is there any angle you can't plug in? Will this y divided by r always make sense? Because we know over here, we can't take the square root of a negative, right? For that function, so you can't plug in negative numbers. Are there any values that you cannot plug in for theta here? So just think about it. If I have an angle, right? So someone's going to give me an angle, okay? I'll just keep going around. Someone just stops me anywhere, right? I just stop, boom, I stop right there. There's an angle. Will I always have a y divided by r? So I just grab a point here. X, Y, R. Will I always have a y coordinate divided by an r coordinate? Will that always make sense to calculate?
Yes.
Yeah. There should never be a problem, right? There should never, ever be a problem. Do y'all agree with that? Okay. So the domain of this, and I'm talking about just the sine function, the domain should be everything, right? All real numbers, any number I want, any angle I want. So the way I'd write that in set builder is I would say all, not x, all theta such that theta is between negative infinity and infinity. That's set builder. As an interval notation, you would say theta is an element of the interval negative infinity to infinity. So those are the two different notations that represent the same answer. All theta such that theta is between negative infinity and infinity, or theta is an element of this interval between negative infinity and infinity. Questions on that? Now, no? So we can plug in any angle we want into the sine function. The harder question is, what is the range? So let's talk about range on this example over here. When you look at this function square root of x, if you go back to college algebra, if you were to graph this function in college algebra, hopefully you remember it looks like this. And so the range are the y values that come out. And from looking at this, only 0 and positive y values come out of this. Right? So you're only going to get outputs of that function that are positive values, right? You could get 0, square root of 0 is 0. But other than that, you're never going to get a negative number out, right? You never plug in a number into this, take the square root and get a negative number, as long as we're not talking about imaginary numbers. So what about this though? What about sine? This is a harder question. Can somebody tell me what the outputs of the sine function have to look like? Is there a range value for them? And you have to be able to explain why if you're going to give me the answer.
Wouldn't it be like 0 to infinity?
Okay, so that's a good guess, I guess. You could have, okay, so your y coordinate, right? You're always going to be doing, this is the output, right? That's your output. That's what comes out of the sine function. So let's look at the numerator. The numerator is y, right? Can y be positive? Yeah, right, okay. It would be positive if we were in the first quadrant or the second quadrant, but could y be negative? Y could also be negative if we're down here, right? In the third or the fourth. So our y's could be plus or minus. What about our radius? Always positive, right? So it looks like we can get outputs that are both positive and negative, right? Now, the question that Anna Marie was thinking, okay, so maybe it goes, the outputs are always going to be between negative infinity and infinity, right? What do y'all think about that? Think about what the ratio is. I'm going to draw a big triangle under here. Let's take this one right here. If I were to draw a triangle, here's the y, here's the r. Can somebody tell me which of these is bigger? What's bigger, the y or the r?
R.
Always or just sometimes?
Always.
Should be always, otherwise it
Always,
wouldn't be a
right?
triangle.
Always. It should always be the same, right? Because, I mean, sorry, not the same. I said the same. I was thinking out loud. This y value is not the hypotenuse. The hypotenuse is always the longest side, isn't it? Always the longest side. So there's this y value will never be bigger than the r value. Never be bigger than it. Which means that if I take a number, y, and I divide it by a number that's bigger than it, that number must be smaller than what? Just take some numbers in your head, divide them by a bigger number.
1.
It has to be less than 1, right? Don't they have to be less than 1? 7/8, right? 7/10, 8/13.
So sine
One-
always has to be a fraction.
Yes, I'm going to say fraction, but fractions can, you know, like 4/3 is a fraction, but it's not smaller than 1, right? So it's a little bit more than that. It's this up here is smaller than that, right? The y is always smaller than the r. So anytime you have a number that's smaller than being divided by a number that's bigger, right? Just take any number and divide it by a bigger number. That number must be less than 1. Do you all agree with that? Must be less than 1. Now, it could also be negative because remember the y could be negative and the r could be positive. So you could get a negative number, but it would still be less than 1. So here's what it's looking like. Just if I were to look at the outputs right now on a number line, if I'm looking at the outputs on a number line, I know that, well, I could get 0. If y is 0, then I could get 0. Here's 1, here's -1. It looks like we're going to get everything in here and everything in here. What about 1? Could I ever get 1? Wouldn't these have to be the same to get
It would
1?
have to be an equilateral triangle, but then it wouldn't apply to this theorem.
Equilateral? If I tell you that y and r are the same number, then can that be here somewhere?
No,
Let me come down here. Can y and r ever be the same?
No.
no.
How about here? How about that point? What's the x there? What's the x? If I'm up at pi/2, what's the x? The x
0.
value would be 0, and the y value would be y, right? Whatever y is. But then what's the radius? Isn't it just also y? Isn't that also y? Just how high you are? And so what would sine of this be? I feel like I'm losing people here.
It'd be 1.
It'd be 1. And we knew that. Remember from the unit circle back here. Where's that? Am I on the wrong thing? Yeah, from this. Remember, if we were to say what was we didn't do it here, but if I say what's sine of 90 degrees, right? Go to 90 degrees, look at the y coordinate, it's 1, right? Sine of 90 should be 1. So what I'm trying to get at here is if we're anywhere in the first quadrant, right? If we're anywhere in here, then of course the y coordinate will always be smaller than the radius. But when you go straight up, that's when the y and the r are the same. And then when you come into the second quadrant, it's the same thing. The y will be smaller than the r, right? And it'll keep doing that. And then you start going over here. Now you're going to get negative y values. But when you get to the bottom here, this is going to be 0 and this will be negative y, right? And this distance here, the radius will also be y. So if you take the y coordinate and divide by this, you get negative 1. So what I'm trying to say, if you're not following all of this, hopefully it'll start to come together over time. What I'm saying to summarize all of this is that for the sine function, we can plug anything we want into it, all right? You can plug any angle you want into the sine function. The outputs must be between -1 and 1. And that's what this first thing is saying. If we look at the sine function as a function of theta, the domain is all real numbers. You can plug anything you want into it. The range is every real number in between -1 to 1 inclusive, meaning -1 can come out and +1 can come out. Right? So if we ever go to graph this function, because we are going to graph it, when we draw it, we should be able to draw it in both directions forever. And the outputs should always be between -1 and 1, right? Now I'm going to cheat. I'm going to get ahead. I'm going to graph it for us, okay? There's the sine function. Okay, we're going to become very familiar with the sine function later. But you can see that if I go to the left or the right forever, I have graph, okay? So the domain is everything, as opposed to something like square root of x, where that graph doesn't exist over here because you can't plug negative numbers in, right? So the sine function has inputs everywhere, but notice the outputs are stuck between -1 and 1. Right? You never get a value out that's bigger than 1 or -1. You get everything in between. And then you get the sine curve, which I know some of you are already familiar with the sine curve from some other classes, right? We're trying to build that function in this class. We're trying to figure out why is the sine function look like this. So all I want you to know now is that from this definition, sine's domain is everything and the range is everything between -1 and 1. Now, what about cosine? Well, for cosine, same story. If you have cosine of an angle is defined to be the x coordinate over r, then it's the same exact thing because the x coordinate will always be smaller than the r except when x is r. And that happens at these special places here and here. This is where you get the 1 and the -1 for cosine because the x and the x and the r are the same values here. Otherwise, this ratio is going to be a number smaller than 1. So we have, for cosine, the domain is all real numbers, and the range is, again, between -1 and 1. So sine and cosine have the exact same domain and range. Exactly the same. Are there any questions? Tangent is harder. Okay? Tangent is harder to comprehend. So let's take a look at tangent. By definition, tangent is y over x. Now, we can have a problem here because if we pick an angle, right, we just go and like pick some random angle here, pick some point, call it xy. We should always be able to take the y and divide by x, right? We should be, unless what? Unless our angle lands where? Where would we have a problem with this division?
On any of the axes?
Any of them?
Well, no, not any of them. You'd on y0. Or
You have the right idea. Think
or
about
sorry,
the
x is 0. I'm sorry,
x-axis.
x is 0.
Yeah, so look, this division won't be defined, right? If we try and plug a 0 in for x, right? And where does that happen? X is 0 here, right? Any point here would be 0 and then some y coordinate. Or here, because that would be 0 and then some y coordinate, right? If I try and do tangent at that angle or this angle, I'm in trouble. Do y'all agree? It's undefined. So when we're talking about domain, domain, like what can you plug in for theta? It's not all real numbers like it was with sine and cosine. See, with sine and cosine, when I was doing this R down here, this radius, that can never be 0. The radius can never be 0, all right? Because once you draw a triangle, you're gonna have a radius. But with the tangent, it is possible to have the x be 0. So how do I say this? How do I say this? It's not all real numbers, right? What can the theta not be? Y'all tell me what theta can't be. So
It can't be 0.
theta cannot be what? What's this angle here?
90 degrees.
90 degrees. Okay, I'm gonna write 90 degrees. What else can it not be?
270 degrees.
270 degrees. Do y'all agree with that? Now let's write it in radians also, so we have it. It can't be pi over 2, and it can't be 3 pi over 2. Do y'all agree with that? Yes? Are those the only two answers?
I
What
feel-
about negative pi over 2 or negative 90 degrees? Can't be that either, right? Any coterminal angle. So like if I take this angle here, what about this angle that goes around once and then comes back and stops there? I can't plug that in, can I? To tangent. I'm going to have a problem. I can't do this angle. I'm running out of colors. I can't go backwards like 7 times, you know, and then stop there at the top. This is a problem, everyone. Do y'all see that? It is a problem. If I could like go and like shake you right now, I'd shake you because this is an important topic. This confuses students. This is where people start going off the rails in this class, because our domain has problems at an infinite number of points. It's not just 2 points. It's not just 90 and 270. It's an infinite number of places that this function's undefined. Now, I'm going to show you the graph of it first, and then we'll come back and talk about how we're going to figure this out. But here's the graph of tangent. There it is. Okay, this looks like a mess, doesn't it? Do you see all these? Do you see how this is? Let me see if I can draw on this. I'm doing it in blue. Do you see how this graph goes like that and goes up like that? There is a vertical asymptote right here. There's another vertical asymptote right here, and another one right here, and another one right here. And there's an infinite number of vertical asymptotes, okay? Infinitely many of them. Get back, come on. I'm zooming out so you can see tangent, all right? There's an infinite number of vertical asymptotes. And I'm gonna have this x-axis, let me go pi over 12. Okay, so let's look at where is this first vertical asymptote happening? Pi over 2. Okay, didn't we say you can't plug in pi over 2? The next one's happening here at 3 pi over 2. Didn't we say we can't plug in 3 pi over 2? Yeah, but there's also 5 pi over 2. There's negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2. And I could just keep going and going and going and going, right? And going in both directions forever. So how the heck are we going to write this, right? I almost said the real bad word because I want you to remember this is a problem, all right? You ready? Here it is. I'm going to show you how. I'm going to clear your brains first. I want to get rid of all this. I want you to just think about this. If you can make sense out of this, your life in this class is going to be so much easier. If this causes you a problem, we need to talk. All right. So here's the way I'm thinking about this. There are 2 places where I have problems. I have problems anytime I'm here, anytime I'm here, right? Because at those points, I've got 0 as an x coordinate, and I cannot divide by 0. right? So I would like to somehow represent both of those points not in a list, but in a way that makes sense to you and makes sense to everybody who would read this. So watch what I'm going to do. I'm going to say, okay, this from here to here is pi over 2. All right, everyone agree? That's pi over 2. So I'm going to write this. Theta cannot be pi over 2. Now, here's the tricky part. Pi over 2. Now, what is the angle that goes from here to here? How much is that rotation? To get from there to there, what's that rotation?
180 degrees.
Okay, 180.
Pi.
But as radians, it's pi, isn't it? And to get back to that other red dot, wouldn't that be another pi? And then if I want to get back to the other red dot again, I just add another pi. So what I'm going to do here, I've recognized that it's just to get from dot to dot, I just have to jump by pi each time, right? I'm going to say plus k pi, plus k pi, where k is any integer. Now, if you don't remember, we talked about this before. What's an integer? An integer is any number like -3, -2, -1, 0, 1, 2, 3. Any of your counting numbers, positive and negative. And this would be the way we write, well, we probably write it like this. We'd say the domain is the set of thetas, the angles, such that the angle is not pi over 2 plus k pi. Now let me try and convince you that this gives us all the answers. Okay, so what if k is 0? If k is 0, what does this give you? If k is 0.
Pi over 2.
Pi over 2. Okay, what if k is 1? Well, that would be pi over 2, and then you're going to add how much to it?
Then it'd be 3 pi over 2.
Boom, you'd be down here 3 pi over 2, right? So you start at pi over 2, you add 1 pi to it. Now, what if k was 2? Well, then you go to pi over 2, and you would add 2 pi's, and you'd be back up here, right? But it would be a different angle. And if k is 3, then you go to pi over 2, and you would add 3 jumps of pi. 1, 2, 3, and you'd be back down there. It wouldn't be 3 pi over 2, but you'd be at the same, it'd be coterminal, so you'd be at the same place, right? Y'all see how this k pi gives you everything?
It would be the same thing
Oh.
as if negative, correct?
Say again?
It would be the same way as if you're going negative, you just go the other way.
Yeah, and so if we do pi over 2, let's clear these out. Let's say we did pi over 2. I'll leave that one there. And this time we do pi over 2 plus negative pi. So that's the negative integer, right? So you go to pi over 2, boom. And now you go opposite direction by pi. So now you go back by pi. And now you're at, you would actually be at negative pi over 2. And then if we did pi over 2 minus 2 pi, then you would start at pi over 2. And then from there you go back 1, 2. So now you'd be here, but it would be a negative angle. So by having this very clever way of representing this infinite number of answers, it's a very condensed way of writing an infinite list of numbers, right?
Can I ask a question?
Yep.
So k is technically just how many times you're jumping?
That's right. And we're saying that k can be any integer.
Okay.
Okay, so k is gonna, see, we have to have a way of writing an infinite number of answers, right? Because we couldn't list them all out. It would take us our whole lives. We'd run out of time and die, and we still wouldn't be finished with the list, right? So we have to have a way of doing it in a way that it makes sense, but we can stop, right? So this is the way we do it. Okay, that's the domain. Now the range is tricky. The range is tricky because the outputs of this are different than sine and cosine. I'm not going to get into it right now because we need to move on. But the outputs are going to be all real numbers.
So
when you do this ratio, we are not stuck. Last time when we were doing sine, we said, okay, the y always had to be smaller than the r. But in this case, the y could be bigger than the r or smaller than the r. Sometimes, sorry, The y can be bigger than the x or smaller than the x, or you could have positive and negatives. It just depends on what quadrant you're in. So basically every possible number can come out of this. You can have any positive number and any negative number come out. So the range of this is negative infinity to infinity. And that is what it says here. Tangent, all real numbers, okay, domain, all real numbers except integer multiples of pi over 2. That's what I just said, right? Well, hold on. Except odd integer multiples of pi over 2. I don't like the way they write that. I don't like that they put odd there. Integer multiples of 2 would be fine. Odd integer multiples of 2, I need to look at that. I think that's a mistake on their part. Okay. So, all right. So now the range here is all real numbers. Okay. So everything comes out, and you can see from the graph that was very different than the sine function, right? Sine function was stuck between -1 and 1. Tangent function is all the outputs comes out here, goes down to negative infinity. But we have vertical asymptotes. All right, how are we doing? 10, I only have 9 minutes. Okay, let's talk about the cosecant. You know what, hold on. Yeah, let's talk about cosecant. Cosecant theta, by definition, remember, that's the reciprocal of sine, right? And sine is y over r. So cosecant should be r over y. Now, let's talk domain. Are there any issues we would ever have where we plug in a theta and we have a problem? Division by 0 would happen when? If what?
When we hit the x-axis.
X-axis. So if y is 0, does everyone agree? If y is 0, we have a problem. So watch how I'm going to do this. Just like I did before. I know that I have a problem if my angle is ever here or here, anywhere on the x-axis, right? Because here I'm going to have an x coordinate, but my y is going to be 0, right? Same with this. This will be some negative x value, and my y will be 0. And I'll have a problem because I cannot plug 0 in for y. So I need to somehow tell you all the infinite number of answers this would be. So I'm going to say that it's the set of theta such that theta cannot be, now let's see if anyone picked up on this. I'll take a volunteer at this point and see if someone understands this. Anybody?
Would it be
Would
0?
it be pi
0.
plus k
Hold on.
pi?
All right, can't, wait, you said pi plus k pi? Okay, hold that thought, Maddie. Cameron, what did you say?
I said 0.
Okay, 0. So I'm going to do these in that order. I'm going to start with Cameron, then I'll come to Maddie. So Cameron, you said 0, right? So this is 0 degrees. Like just point it out to the right. That's 0 degrees, right?
Mm-hmm.
So I'm going to do it in radians. That's 0. Now, Cameron, how could you jump to the next one? How much would you have to jump by to get to that one?
Hold on. Wouldn't it be
Or a full rotation's 2 pi, right? So you want to do a half rotation,
pi?
pi, right? And then Cameron, could I jump by pi again to get back here?
Yes.
And then could I jump by pi to get back to that one?
Oh, okay. So it's kind of like the previous problem that we did.
Exactly like the previous problem, but it's where we're starting. And the previous problem we started pointed straight up. So we started at pi over 2, and then we added multiples of pi to jump around, right?
Yes.
Here you said, let's start at 0, and then let's add to that some multiples of pi, and that should get us jumping around.
Oh, okay. I see. It's the same thing. We're just starting at different spots.
Starting at a different spot, exactly. So that would work. Do y'all see that? says, hey, look, your theta can be anything except you can't be at 0 or any pi multiple added to it. So you can't start at 0 and then add a pi or a 2 pi or a 3 pi or a 4 pi, or you can't go negative pi, negative 2 pi, negative 3 pi. You just got to stay off those 2 points. Okay, that would be correct. Now, Maddie said something different. Maddie said, how about we go theta such that theta is not equal to, and then Maddie said pi, right? You wanted to start at pi and then say the same thing, plus k pi?
That's what I was seeing initially, but
It's
I
right.
understand
That
why
is
you would
correct.
start with 0.
That's correct. The only difference between these two answers is where they're starting.
You could
See,
also start
Cameron
at 2
said-
pi, correct?
What's that?
Couldn't you also start at 2 pi?
You can
Because that
start,
would be
as
the
long,
same as
you can
0.
start at any angle that lies on these two. See, Cameron said, let's start at 0 and just start jumping by pi's. Maddie's saying, let's start at pi and start jumping by pi's. But then someone else could say, let's start at 2 pi and start jumping by pi's, right? It doesn't matter where you start. I mean, well, it matters where you start because it's the cosecant function. You just have to pick, you just have to come in here and pick an angle, any coterminal angle for those 2 points. Once you have that, then to get all infinitely many, you jump by pi. Okay. I know this is a little confusing. Let's do tangent, because tangent's going to really test your mind on this. Oh, by the way, the range of this is everything. Okay. Sorry, not everything. It's tricky. Okay, so think about this. Remember with cosecant, with sine, we said you had to be between -1 and 1. If cosecant is the reciprocal, then you can't be between -1 and 1. You have to be outside of that, because it's the ratio flipped over. So I'm going to show you the graph of cosecant. This one will blow your mind. Cosecant x. There it is. And also I'm going to graph sine x here with it. Okay, so there's cosecant. Cosecant's in red, sine's in purple. So notice where we have the problems. Do you see we have a problem at pi? Do you see this looks almost like a little parabola? At 0, we have a vertical asymptote. At pi, we have another vertical asymptote. And we have almost like this parabola that's stuck between these two verticals. But it touches the top of sine. It's weird. And then on the other one, between pi and 2 pi, you have this upside down looking parabola, and it's infinitely many of them and crazy looking function, right? Don't worry, we're going to spend time graphing these. We're just getting an introduction into this right now. So back to the domain. I'm almost out of time. Cosecant, all real numbers except integer multiples of pi. And then the output is all real numbers greater than or equal to 1 or less than or equal to -1. So it's basically everything above the sine and below the sine function. I just want to talk to you. I want to talk, yeah. Let's just talk, you know what? I think that's probably, I have 2 minutes. I can do it. Okay, let's just talk cosecant real quick. Cosecant, no, secant, I mean, secant theta. I want to talk domain. Okay, the secant function by definition is r over x because it's the reciprocal of cosine. So let's see. Is Quinn here? No Quinn? Allison? Oh, Quinn is here. I see Quinn. Quinn, do you want to respond or no?
I'm not really sure what's happening. Like, oh?
Yeah, I'm here.
Yeah, I'm not really sure about what's going on.
Okay.
I
You
don't
should
really
ask
understand.
questions.
Yes, sir.
Remember, everyone, when I'm asking, does anyone have questions? Y'all understand? Like, that's your time, right? So everyone make sure you're asking me, stopping me. If you're not asking me, then this train will just leave the station without you. Okay? And that's the way math is with pre-cal, cal 1, cal 2. If you don't ask questions, these courses will just, you'll just be standing there looking around like, where's everyone? They're all gone. They all left. Okay. So ask questions. Don't be afraid. All right, we're moving on then. Let's see. Angelique?
I'm here.
Okay, so Angelique, where are the two places that I have to be worried about here?
It would be on the y-axis.
On the y-axis. Okay, so I have here and here. So Angelique, if you're going to give me the domain on this, tell me where theta can't be.
That would be the same as it was for tangent.
It's the same for as it was for tangent. I can't be, so go ahead and let's start off. Let's start off, we could start off here at pi over 2, couldn't we?
Yes.
But let's be weird, let's be oddballs, okay? Let's start this way. Let's start right there at negative pi over 2. Can't be negative pi over 2, right? Can't be.
No.
But then I just add to that k pi, and that should allow me to jump from there to there and then back here and back there. It doesn't matter, I just keep jumping around. That would be sufficient. Okay, we're out of time. So you're not going to be able to do all the homework for 7.5, but try it. We were almost done. We still had to talk about this periodic thing. I think you could figure these out. With what you know already, I think you could figure these out. You don't need anything special to do these. All right, so let's say for next
Did you mean 7.3? Sorry.
Sorry? What was that question?
Did you mean to catch up on 7.3 or 7.4? I'm sorry.
7.4. 7.4, you need to finish that up, but 7.5 we've covered now.
Yeah, correct.
So try and get up through 7.5 by next class if you can. If you can't get to the end of it, that's okay. I think the deadline on it, remember where I put my deadline. I'll just go see. If you got to go, you can go, but
just so I did it, and I guess it's just a computer issue to whoever else is going to do it. But 7.5.6.1 or 6.1, just you're going to have a denominator. Just make sure you write it correctly because the computer doesn't read it correctly. You just might have to flip your numbers around, your equations around, but.
Okay, yeah, I'll do the homework solutions on them and I'll see if I run into that. But okay, so it says here that this 7.4 is due on the 27th. That got messed up. So let's say the 7.4 and 7.5, let's make those due before class next time. Do as much as you can, all right? If you can't finish it, that's okay. And you can, we can get an extension on it and stuff like that. But let's shoot for getting ourselves through 7.4 and 7.5 on the homework by next time. Because the next section is we're going to start graphing these. Okay, we start drawing the graphs. All right. Okay.
Thank you, sir.
Everyone have a good day. Glad we're
Sorry,
all.
I have a question. Sorry.
I'll hang out. I'm going to turn off the recording, but I'll hang out for a minute.